Good morning, everyone. My name is Nalin Arachchilage, and I'm an associate professor in cybersecurity here in the School of Computing Technologies at RMIT University, Australia. I'm also an honorary associate professor at the University of Warwick in the UK. So I'm interested in a broader spectrum of cybersecurity and privacy, ranging from socio-technical aspects to more technical aspects. In my research, I applied human-computer interaction methodologies together with qualitative, quantitative, as well as machine learning and natural language processing algorithms to grapple with cybersecurity behavioral problems. The overarching objective of my research is to design and develop secure and privacy-preserving software systems. Today, I'm going to be talking about empowering software developers to build privacy-preserving software systems. How much of privacy we are trading off for convenience? Back in the day, Cambridge Analytica, a UK-based company, had access to over 80 million US citizens' information from the plugging tools that they have developed on the Facebook developer platform. They use this information to escalate US elections. So you see that leaving little nugget of information from your life, it doesn't make a big deal, but at the end of the day, you will become the end product. That is your information you are trading off for your convenience. Even, this is a good example, so privacy breaches could even escalate to as a threat to national democracy. Another good example, Amy Safe App Driver here in Australia, which provide roadside assistance, especially for the newcomers for driving. However, their GPS logs not only reveal or collect where you travel, how fast you drive, which route you take, which ATMs you stop at, and which medical clinics that you have visited. What happened, even if they collect this information and share this information with other parties, like third party, like law enforcement agencies, like police, they might be able to send you a parking ticket. I'm not trying to design and develop technology against the law, but then the problem is the nitty-gritty aspects of the problem here is how do we get people to consent? Are they aware of how your information is going to collect, how their information is being processed, stored, and shared with the third-party organization? Without them knowing it, can we do that? So that's their privacy. Think of situation, how that is being communicated to the end user. Twitter privacy policy back in 2021, it's 90 pages. You find still it is 90 pages. So in these systems, privacy policy should be presented in a way that has all been designed with the readers in mind rather than lawyers protecting those organizations in mind. A bunch of research scientists from Carnegie Mellon University, Lori Faith Cranner and her group, investigated and identified it would take the average internet user 244 hours to read every privacy policy for every website they have visited in the last 1 year. It is very atrocious if you've got to read every privacy policy of the technology or services or software that you're dealing with, you're using to do your work in the work settings. It is quite impossible to do that because that is not your primary purpose of coming to work. Here is the other example. Updating privacy policy statement. As we may aware of it, in 2014, Facebook bought WhatsApp. However, later they will know users. So updating privacy policy statements. Back in 2014, Facebook bought WhatsApp. In August 2016, WhatsApp announced that it will start to share data with the parental company, Facebook. So the question is how this information is being communicated to the end user. As you can see that they would really want to accept those policies and continue without even them living it. So this is how a good example of how uh, Viber update their privacy policy statement. During the during the Zoom bombing things, we have all been experiencing uninvited guests attending our Zoom meeting. Boris Johnson is not an exception for this. As you can clearly see, we have been experiencing Zoom bombing attack. So that is a software glitch. That is an issue with the software. When they design it, they reveal that Zoom ID, whoever the person got the Zoom ID might be able to access to that Zoom meeting. What happens if they're talking about some sensitive information, some military information during the cabinet meetings or during the House of Commons meetings? So that is going to be quite atrocious. Another example is a Uber data breach. Uber concealed a hack that affected 57 million customers, drivers, and riders' information, including their username, passwords, email addresses, mobile phone numbers, so on and so forth. This information and could be susceptible for various, not only data breaches, but also other attacks as well, such as two-factor authentication break if they're using security questions, or have a phishing attacks, more specific and targeted phishing attack. So what Uber did a naughty thing. They paid around £75,000 to delete this data. As a cybersecurity professionals, we cannot advise organization to do so. In my research teams, we wanted to explore why developers cannot embed privacy into the application, because we have the privacy. Why the various privacy principles are not being incorporated into software? Well, the users can consume the services through the software while preserving their privacy. What we did was we wanted to identify the problems, the struggles, what's holding software developers back when they're asked to embed privacy into the application. Developing system that preserves end user privacy. So we investigate with the 36 software developers who have more than 5 years experience in their software development job. So we provided them with some sort of instructions, clear instructions through the experimental protocols that we developed, asking them to embed privacy into the applications, and also where we wanted to be able to identify the problems, issues that they're facing when they're asked to implement privacy into the applications. We initially got them a task, hospital scenario, and asked them to say that identify the scenario when they implement various systems where they need to think about privacy using use case scenarios. We have the users, we have the cases, and we wanted to understand when the users are interacting with some of the business cases, how they consider implementing privacy through the use case scenarios. So they found some practical issues when attempting to embed privacy into the applications. They found it difficult to relate privacy requirement into engineering techniques. We do have a software requirement, specific even security requirement, but when it comes to privacy requirement, it is difficult to differentiate. So mainly they have a lack of knowledge on formal established privacy concepts such as general data protection, regulation, fair information, practices, privacy impact assessment, privacy by design, and all of these concepts, they are there, but they don't know how to put them into practice. So those concepts like general data protection regulations, fair information practices, privacy impact assessments may not work in development context unless they are provided a systematic way or systematic approach, helping them to put those concepts like general data protection regulations into software application. So, when they have a lack of knowledge, they rely on their colleagues' personal opinions, and complex system requirements seems to take precedence over the privacy requirement, resulting software applications with a limited or um, not at all implementing those privacy. So we develop a systematic approach, helping software developers to embed privacy into the application. So what it our development method has got two phases: A, understanding data, then system design decisions. So understanding data, the developers, when they gather the requirement, they should be able to understand how to design systems using functional requirement, non-functional requirement, as well as security and privacy requirements. So when we design systems, they should be very careful about how they collect people's information, how they're going to store their information, how they're going to share their information with a third party organization. This is where the fundamental concept are important, because we are dealing with end user data. So we wanted to be able to think about data, how to minimize the data when we collect through the system. What we did, we calculated the perceived privacy risk based on the sensitivity, relatedness, and visibility. How sensitive that information, username, password, or credit card numbers, how visible they are. Are we comfortable with sharing on Facebook, publicly sharing our credit card numbers or passwords? Or relatedness, relate to the application scenario. Healthcare might work quite differently to the banking, where when it comes to education sector, it might work differently. Think of situation like when we talk about um, emails. So emails are meant to be exchange ideas, documents, thoughts during the personal life as well as working context. However, think of situations. So the email addresses are there or meant to be sharing with people. This is where other people are going to communicate with you. But would you use email address to log into a mobile banking client or browser-based mobile banking applications? Of course not, because you might be susceptible for phishing or two-factor authentication or phishing attack. Therefore, relatedness would be really, really important. That's why you're using a separate ID to log into your mobile banking client together with your password. So, based on the sensitivity, relatedness, and visibility, we develop a mathematical formula to calculate individuals' perceived privacy risks when we are collecting those each and every data point through the systems. Then we prioritize them: high priority, medium priority, and low priority. Those most sensitive information, since high risks are the ones, data points where very sensitive, so we need to deal with carefully. So then we will design the system in a way how we should share those high sensitive data point, how we should collect through a secure channel, transport layer security, how we should process and store their information through an encrypted way, how we should share this information with a third party organization or maybe parental company. So in that case, we are using secure channel like transport layer security or through an encrypted means, where the developers will then be able to make system design decisions, how to collect information, how to design the interface to collect that information, how to store their information, how to share this information with a third party company or parental company. So in that case, they would be able to deal with very carefully with the high sensitive data, but with the medium ones, perhaps the low sensitive data, they might be able to sometimes ignore it, or maybe if they cannot mitigate the impact, that risk management, so they might be able to transfer the risk to a financial or insurance organization. So we developed the model and we ran the model with 149 software developers, real world software developers who have got more than 5 years experience on average. So they found this is relatable to their day-to-day task, and they found it very useful. However, the other problem they experience is they need to get this model into practice. They need a bit of hand to transfer this model into practice when they're developing software in day-to-day life. So we develop a serious game design framework as an educational intervention that enhances developers' secure coding behavior through motivation, that we potentially focus to improve the developers' coding experience in terms of helping them to develop privacy into the application. So we wanted to teach how that model works in real life through an experience. Here is the game design framework we developed, which enhances the secure coding behavior in terms of helping them to develop privacy preserving software systems through their motivation. So developers, we wanted to improve developers' secure coding behavior through motivation. Initially, they need to perceive such a threat, privacy threat. Think of situations. This is where we're going to design some scenarios like Zoom bombing. We in the game design platform, we are taking the developers or the game players at the time, software developers, through a scenario like Zoom bombing scenario, and let them to experience when there is a privacy glitch. If they fail to implement privacy into the application, what would be the severity? What would be the susceptibility? If the particular privacy breach occurred, what would be the financial loss to the organization, severity, or reputation damage to the organization, that is severity. So once they perceive such a threat, they feel like, wow, there is a threat. So then they would need to develop their self-confidence, what we call self-efficacy. So this is where we are going to teach our data minimization model that we develop through Bloom's taxonomy. It helps developers to understand the concept, digest it, and put them into practice in a pragmatic way. We also use adaptive difficulty using, we also address the adaptive difficulty using reinforcement learning. This is where when we generate those teaching content, so the software developers should be presented with those teaching content in a way they would be able to engage with it, engage with the difficulties. For example, if you presented with a very easy concepts and easy to understand, not more challenging, so you find obviously frustrating with a gamification platform. Something you might be able to find it like very difficult to understand and engage and answer these questions or go through that education element, or the questions that we presented or tasks we presented to educate yourself. If they're too difficult, so then you also might get frustrated with the gamification platforms. So those teaching content are presented to individuals using Q-learning approach, where it will adjust to by looking at the people. So this is an AI-powered serious game platforms to improve software developers' secure coding behavior so they can develop privacy preserving software systems. So what we are going to do next is we wanted to empirically investigate the developed framework, because they are there. We wanted to investigate through statistical investigation through the using actual software developers. So we wanted to be able to incorporate those elements then into a gaming applications. So like I mentioned that earlier, perceived privacy threat, how can we demonstrate that? So where we could take them through some of the data breaches and get them to expose to it and then see how vulnerable they are, if what the severity, what the susceptibility, if the particular threat occurred, what would be the financial loss, what would be the reputation damage through data breaches. So in that case, what are the repercussions, consequences? So once they feel it, we need to develop their confidence. Confidence has a correlation with knowledge. This is where we are teaching our data minimization model. We really need to think about what's the best way in an attractive or way where we could design, get software developers to incorporate those elements which we have identified, like perceived threat or various teaching elements, like co-design approach to incorporate those framework into a real world gaming applications. And then we wanted to investigate how developers, once we develop the fine-tuned version of the gamification tools, we wanted to recruit software developers who have a plethora of experience working as a software developer in the industry or designer, architect, team leader, where we wanted to see after their engagement with the developed gaming uh, program, we wanted to be able to investigate how impact will be on the framework, original framework which we have developed. So that is the only thing. But also, before stepping into that, we also wanted to be able to investigate a threat modeling thing, because when developers are engaging with the real world gaming applications to learn how to write better privacy code in their applications or in their software that they developed, we will be able to collect through the AI technology, we will be able to collect where their weaknesses are, because this is something they do brilliantly well, but this is where they need a bit of learning. So those learning ones where we could collect through AI technology, and then we would be able to develop a threat model understanding how the attackers would leverage the attacks through uh, um, manipulating software developers, because their behavior is the huge issue. So we will be able to develop threat model understanding how the attackers would leverage their attacks through manipulating individuals to perform or leverage their attack. Or in other words, we would be able to develop threat model understanding how developers' behavior would open up the back door for those data breaches or privacy breaches, where it helps the organization to better understand how they need to train and upskills their developers to write a better privacy code. So that's exactly what we are anticipating to work on in the near future. That's the end of my presentations, but we would not be able to achieve this much without support from our current and former PhD and MSc research students. Huge thanks goes to them, and also they are the heavy lifters. They are the ones behind this work, and they are the ones who are been working hard to accomplish this work, as well as I would thanks to industry collaborators such as Cyros and other organizations who supported us financially and knowledge-wise as well. I also would like to thank to my academic collaborators across the UK, Canada, Australia, as well as New Zealand, um, in research capacity. Thank you very much. And here is the list of references. Please feel free to go through. And if you have any questions, please feel free to drop me a line. I'm more than happy to answer. Thank you very much for that.